For more than 45 years, customers turn to Nexeo Plastics for our plastics resin expertise. As a distribution partner, we understand that the right product needs to balance ever-increasing demands for quality, competitive costs, and sustainable solutions. With thousands of products from world-class suppliers, our team of experts can deliver the flexibility and innovative solutions you need when and where you need them. At Nexeo Plastics, expect more so you can do more.
Hello again, everyone. I'm Joe Pryweller, Conference Director for Plastics News. Welcome to Ask the Expert, our new live stream series. Ask the Expert is your chance to engage with professionals, to address the current business environment, to discuss best practices, and most importantly, ask some questions. The topic of this series is improving operations. Today's experts are Larry Hunt, Vice President of Commercial Operations, and Chuck Kritz, Senior Technical Representative with Nexeo Plastics. Larry and Chuck will discuss methods to approach operational efficiency and capitalize on undetected potentials. They will answer your questions after the presentation. To submit a question, email pnevents@crane.com, or if you are watching along on LinkedIn, Facebook, or YouTube, submit your questions through those platforms. With that, I will turn things over to Larry Hunt and Nexeo Plastics. Take it away, Larry.
Thanks, Joe, and thanks everyone for attending the webinar today. My name is Larry Hunt. I'm the Vice President of Customer Solutions at Nexeo Plastics. I have over 36 years of experience in the plastics industry, and I'll be kicking us off today, and then I'll be handing the heavy lifting over to my colleague, Chuck Kritz. Chuck has over 35 years of experience and is trained in statistical process control, ISO auditing, and has spent the last 13 years with Nexeo helping our customers solve technical challenges. The format for the webinar is that we'll be talking for about 10 minutes with formal presentation, followed by 20 minutes of Q&A from the audience. Next slide. And of course, you know, for your reading enjoyment, we have our standard disclosure. So let's move on and get it started. So improving operations. The series is about improving operations. When I think about improving operations, I really go to improving operational efficiency. And operational efficiency leads me to think about productivity, which ultimately leads me to think about profitability. And so every facility and every operation has some areas where we might say there's some holes in the floor where a few pennies fall through. And you know, with the pressure that's facing by the processor community, you're constantly forced to produce a higher quality part at a lower price. To provide more documentation, more real-time data, more service, it's imperative that you guys put all those pennies back in your pocket. As a leading resin distributor, we think there's two areas of expertise that we can help share with you today from dealing with thousands and thousands of processors and SKUs. Those two areas are, one, solving inventory challenges, and the other is the ability to see the most common operational issues that affect productivity across our customer base. So our goal today is to cover a couple of these topics, provide you with a checklist or a pathway to productivity. And at first glance, you might think you have these areas covered, but again, a deeper dive may help you uncover a few pennies to pick up along the way. Next slide, please. So the first one I'll talk about is inventory optimization. It's our first checklist item. And the goal, of course, is to balance an appropriately lean inventory with the ability to be flexible in your production variances. Well, we all know what's happened recently with the COVID demand. That whipsaw and the variations in demand over the last few months has disrupted everyone's planning cycles. From processor to producer, our historical patterns have been decimated. So the question is it time to reset your settings? And so I think about this as your new normal operating rates become more clear. It's very important that, more important than ever really, to make sure you're working with your supplier to provide like a 30 and a 60-day forecast to ensure the settings all through the supply chain get reset. Again, all the way to the producer. Based on your new demand requirements, you may need to reset your buying patterns. So work with your account manager to make sure you have the customized inventory solution that helps optimize your inventory investment in a post, kind of recovering from COVID, uncertain demand scenario that we have today. So that's inventory optimization in terms of our first checklist. The remainder of the discussion will be focused on a checklist of operational considerations. So at this point, I'll turn the microphone over to Chuck Kritz to lead it from here.
Thank you, Larry. Good day, everyone. On a daily basis, I visit plastic processors with various levels of proficiency, but one thing they all have in common is a desire to produce repeatable quality product for their customers. We can deliver on-time conforming product for years, but will jeopardize our business relationships if we handle one shared quality concern poorly. In an effort to standardize communications and expectations, ISO quality management techniques are implemented throughout the whole supply chain. These systems require large investments in time, capital, and resources, but pay huge dividends when done correctly. When we validate a process, it provides a blueprint for success, but this recipe of inputs only produces consistent outputs when we are observant and in control of the variables in our operations. It can be a point of frustration when the blueprint is followed, but the output is non-conforming. But what has changed? Static conditions become dynamic with the inherent change that occurs in all equipment, tooling, and material. This is hard enough to control with dedicated equipment and product lines, but increases in complexity for custom processors using shared equipment for multiple product lines. The navigators of this landscape who are most successful are those who both record settings, but also monitor process feedback and part weight, which are good indicators of change. Next slide, please. In a scenario that has unfolded identically numerous times, I recently visited a processor to help troubleshoot a material complaint. Upon arrival, I was told they had run this job following the validated process in the validated equipment numerous times with no issues, and troubleshooting efforts had identified the only change as a new material lot number, which was producing parts with burns and black specks. When we got out to the machine, I compared the validated process settings to what was running, and sure enough, everything was set accordingly and inside supplier recommended ranges for temperature settings. The nozzle temperature was set at 550 degrees Fahrenheit, but when I put my thermal imaging camera on it, some areas were close to 700 degrees. When I asked the technician if this was the same nozzle they always used, he said yes, it has a 3/16 of an inch orifice, just like the setup sheet. But then he admitted the extended nozzle was for a previous job that needed it, and perhaps is less than ideal for this job. When I showed him the temperature disparity, he questioned the accuracy of my thermal imaging camera. So I took out a handheld pyrometer and was able to verify the steel temperature at 685 degrees. Even though the machine control said the nozzle temperature was at 550, the thermocouple was located too close to the end of the barrel, which was acting as a heat sink, causing the heater band at the tip of the nozzle to call for heat constantly, thus the burning and black specks. We proved this out by putting a normal size nozzle back on the machine, and the issues went away. Details matter. When we monitor process feedback, change becomes obvious. Similarly, mold cooling set points are meaningless if you don't record the gallons per minute and diagram the flow pattern of the coolant, or at the very least monitor steel temperature. The non-return valve or check ring is a critical high wear part of the molding machine that needs to function properly to consistently pack parts to compensate for the shrinkage, which is critical for dimensions. We can learn from and track these dynamic variables by monitoring process feedback, focusing on pressure, fill times, linear injection stroke positions, melt and mold temperatures to isolate if change is occurring in the machine, mold, or material. Most modern equipment has built-in monitors that can be used, and some proficient processors will also have auxiliary monitoring and data collection. Another best practice is to identify and catalog assets like molding machines, dryers, and other auxiliary equipment to ensure the same equipment is used every time, or at least you know when it is not. When we monitor process, the data allows us to observe the effect change has on the process. Relatively mundane differences like the tightness and location of heater bands and thermocouples, the introduction of regrind, dryer capacity size, the production floor humidity levels produce measurable differences. I have even seen functionality differences in pneumatic robotics when they share air compressors with secondary equipment. In short, you begin to understand cause and effect, and this leads to better understanding of how to control variability, like using torque wrenches to standardize heater band tightness as for an example. This serves two purposes: removing variability, and also allows for better troubleshooting, as it's easier to identify what truly is the root cause of change when we can trust the data. Change is inevitable, but we need to understand it and be able to differentiate significant change from irrelevant change when it comes to quality of the part. When change is correctly identified, maintenance can recenter our process quicker, minimizing scrap and downtime. Significant change in some cases could require revalidation to prove out the repeatability and quality of the part. But in most instances, minor changes can just be documented by changing the batch number per our control plans to document any change of manufacturing methods. This gives us traceability in case some of the repercussions from the change are not evident or measurable immediately. Flip the slide, please. So far, I have focused on the equipment non-static elements of manufacturing. However, the same can be applied to the plastic and the raw materials. Like the processors, the manufacturers of the material are subject to the same elements of variability and use batch control to identify material all produced under identical conditions or inputs and theoretically having the same output, giving it a unique lot number. Labels on the packaging of plastics raw material has information specific to those manufacturing conditions. Documenting the information on those labels is often overlooked, but the key to traceability, as there is also information regarding what line they were produced on and in what sequence. Plastics processing is all about introducing thermal energy, reshaping, and then removing thermal energy from the plastic. Keeping accurate records of all inputs into this operation takes a snapshot of the process. When we take an accurate snapshot of success, we can recognize variability and remove it successfully, providing consistent quality product, and most importantly, keeping our validations valid. Back to you, Joe.
Thanks, Chuck and Larry, for a great presentation and showing us how to look for those hidden variables. We're now ready to take some questions. To submit a question, you can email pnevents@crane.com, or if you are watching along on LinkedIn, Facebook, or YouTube, submit your questions through those platforms. Here's the first question. As a medical molder, we do a lot of screw cleanings to prevent cross-contamination, yet we still see issues. Can you provide some insight into best practices for cleanouts?
I can take this one, Larry. So, when molding machines are made, they're fine-tuned at the factory and then released, and people buy injection molding machines. So just keep in mind that every time you take apart the machine to clean the screw, there's things that can go wrong. There's variability being introduced because as you put the machine back together, you've got to make sure that the heating units are all, identical to the way they were before. And, when you monitor the process, you understand that after you put it back together, you may be getting different pressure readings or things like that. And it helps you to better understand, a procedure for cleaning screws and putting things back together and reducing the variability in that process. You just want to minimize that. There's also opportunities to, make things worse for yourself if you are using, relatively primitive tools to clean your screws, like wire brushes and stuff. Those can, cause abrasion and actually eat away at the steel of the screw and the check ring and some of the parts and cause porosity in them, which could eventually lead to burning and black specks. So every time you tinker with something, you just need to be diligent in your efforts to understand when you put it back together, you're back on the road.
Great. Chuck, just to follow up to that too, are you talking about something that should be documented also as far as how you're cleaning your screws and doing some of that work? Are there efficient methods to do that kind of thing?
Well, there is. And the people in the medical world, for instance, who, cleaning screws is a way of life for you. They've bought better equipment like ovens that will burn off the plastic instead of using abrasive tools. But yes, I talked about asset identification before, and if you have serial numbers for your screws and your check rings and things like that, and you know which ones are which, then it makes it easier to put things back together and know that when you do, if there is a difference in the data, it's not coming from a different screw part or something like that. So just documenting and, leaving yourself a bread trail, really.
Right, that's important. Leave some crumbs anyway to follow. What details are needed and should be collected to allow for material compliant investigations?
So, a lot of times, first and foremost, using some of the tools that we discussed today already, you need to determine if it really is a material problem and not something else going on with the molding machine or even the mold. The molds, venting can change. And, when you're injecting plastic into a mold, there's a high shear rate and that eats away at the gates sometimes. And, there's a lot that could go wrong. So, doing your due diligence first and identifying that it is indeed a material problem helps. And then from that point, getting lot numbers, it's always good practice to, if you have parts from a previous run when things ran good, save some of those parts. And maybe even if you can, save some of that resin. A lot of times, if there's a lot specific issue, what you need to collect is some of the virgin pellets of the suspect lot and some of the parts that you're molding that display the defects or the issue that you need to quantify. But if you have a standard to compare that against, in other words, you can also produce previous pellets or previous parts that were good and trouble-free, it really helps. And from a material standpoint, like I was saying, the manufacturers of the resin, go through a lot of the same issues that the molders do, and they change heater bands and they do things like that to their equipment, their extruders. So they keep batch control, and they also sequence every, as the material's made, you can actually, or packed out by a distributor, the boxes are numbered consecutively so that you have traceability. And if an issue did start somewhere along the line, you can trace exactly when it started. So, keying on the information on those labels really helps us paint a clear picture. And then, the material suppliers can really help us troubleshoot and get to the bottom of an issue.
Great. So follow up to that too, I know you talked about identify whether the problem is machine, mold, or material in some cases. How easy is it to separate the two, or are they combined in some cases too to make it more difficult to figure out when you're troubleshooting?
Yeah, and it's hard to tell sometimes at the onset of an investigation, and that's why it's so important to be able to quantify and trust the data. And when we monitor it, when things are going well, it certainly points to obvious areas of concern. When the data isn't replicating what it was before, it provides clues as to whether it's the mold, the material, or the machine. And there's some preliminary troubleshooting steps you can do to eliminate certain variables.
Great. Question that came in through LinkedIn. Are you talking about inline control processes with this?
Well, I'm not clear on the question, but yes. So when you're producing production, having shot-to-shot data accumulate that you can put into statistical process control graphs. Now you're using math to understand your process and the change that occurs. For instance, if you get into a new material lot, you'll look at your pressure data and you'll look at your plastication time, how long it takes for your screw to get back, and you'll see changes in that. If your material ran dry, or if your dryer went empty, and somebody on a different shift saw that and they didn't want to get in trouble, so just threw some more material into the dryer, and it didn't dry at the same level as other material that had been processed, you will see that in the data in live time. You'll see a change, and you'll be able to attribute it to a significant event.
I know we've talked a lot this week at other improving operations. Ask the experts that we've had about production and process monitoring systems and some of that. How important is that, and what are your suggestions there for even a mid-sized molder or somebody to set something like that up?
So it's an initial investment that you have to weigh the pros and cons of, but I would say if you're going to do your due diligence and you're ISO certified and you're using quality management techniques to try to reduce variability, it's really a no-brainer that this is an important step, because like I said before, you need to be able to trust the data, and without statistical process control or being able to evaluate your process feedback with mathematical principles, you're just guessing.
Yeah, definitely. Question, can you define what level of manufacturing change should constitute a new batch number?
Good question. And, a lot of these can be answered specific to a company. When you write your quality manual, if you will, which basically, when you do business with an OEM and, they want to know how you operate, and a lot of times you can spell that out for yourself, what significant changes. There's a portion that's called change of manufacturing methods, and it's a control measure. I would say anything where there's a noticeable difference in the data is significant enough to require a batch change. And that's just to give you traceability. I mean, even if you look at something like packaging, for instance, sometimes you're running parts and, the operator's boxing them and putting them in a poly bag, for instance, and you run out of that certain poly bag. But somebody in the warehouse says, hey, we've got this poly bag here and it'll fit in this box. Go ahead and switch to these for now. That's a significant change, believe it or not. You might think, well, it's just the bag, but it's a change in the environment that those parts are going to be in. The bag could have a slip agent in it or something like that, where the other bag didn't, and it could have an adverse effect on the plastic parts that are in it. So, the more we learn about this business, the more we, realize that there's a lot of booby traps. So traceability is our friend.
Definitely. That helps with repeatability too, I imagine, in some cases. If you're able to trace and keep a standard, consistent operation, right?
Yeah, absolutely.
Larry, this might be a question for you. You mentioned up top about COVID and how that might be affecting resin distribution and material selection in some cases. Do you want to expand on that a little bit and what that's meant for your business and how that's affected work with your customers?
Sure. I mean, so we all tend to work from the processor to us, to the producers, in terms of statistical models and planning cycles and input demand. A lot of it's based on history and algorithms, and so we all kind of work on some level of normal productivity. And what's happened, obviously, with the demand changes through the COVID process is it's just interrupted. All those cycles don't work, right? The algorithms, the historicals, the measurements, the calculations, the settings, if you will, are kind of broken. And you've got some producers that have taken different lines or capacity off stream during the last couple of months, and they're coming back up an intermittent timeline. So it really has, created a big disruption. So I think it's really important to try to, if you can, again, get your best ability to forecast over the next 30, 60, 90 days. Work with your supplier and make sure we understand those needs, and we try to get ahead of it and try to customize those inventory solutions to the reality of your demand cycle right now, as much as we can, try to get ahead of it at this point in time. We have seen some stability July and early August. I hate to use the words returning back to normal, but clearly the production levels are closer to that in the last 30, 45 days than the April, May, June timeframe. So hopefully you guys are all seeing a little bit more predictability, return to your business. But again, right now, the further we can get that visibility out through the supply chain into production, just the more that you'll be secured and reliable to make sure that you have what you need when you need to run it.
Definitely. We're in a bit of a dynamic environment right now, obviously, and you talked about resetting your settings too in some cases. How often should that be done in that type of environment, and what are some of the triggers to reset your settings? Whichever one you want to take that, I guess.
Yeah, I'll take that one too,
Okay.
in terms of settings and inventory, because Chuck handled the settings on the machines.
Right.
But your settings and inventory are really about, matching your demand. Everybody wants to be lean, but I'll call it a balanced, appropriately lean position, right? If you get too lean, you don't have any flexibility in your manufacturing, because the sporadic cycles right now that are popping up, you just won't be able to capitalize on any ramp ups unexpected. So really, again, the point I think is trying to figure out what's appropriate for you to run, what looks like your steady state over the next period of time, and trying to balance that, with your suppliers. Or I would call it a customized inventory solution, right? What is your EOQ and your MOQ, and how can you balance your inventory needs with the optimal supply order quantity? And again, those are very unique to every resin type and every scenario. But now is the time to reset that, right? You take a look at your high runners, your big moving products, and and kind of evaluate what you need and when you need it over the next 60, 90 days, and work with us to try to figure out what's the right balance of inventory and delivery sizes.
Great. This might be for Chuck, with all your experience and troubleshooting and working with customers out there. What are some of the biggest pitfalls you're seeing, or some of the hidden variables, I guess, that are causing issues? And what seems to be a popular area of pitfall, I guess, anyway, so to speak? Or what are you seeing out there as far as some of those variables that could be causing issues?
The nozzle of the molding machine is such a critical area to control. And, that was the one example that I've used, but, and there's others, but, temperature control is not as simple as, setting it and, the machine tells you it's where it's at. There's so many little things that can go wrong that can affect the process. And, when I first got into this business 35 years ago, I was setting up molds and, adjusting processes, and I was having success, but it wasn't until I worked for a company where, we were monitoring process and getting feedback, where you started to connect the dots of, hey, well, look, the pressure's different, or this is different. And then you start to look at the maintenance records and understand what changes occurred to the machine and how that manifests itself. So, the nozzle itself, not a lot of people notice. Like, if you buy an 1/8 of an inch nozzle tip, and that's the orifice size, that's 125 thousandths, but they make them about 118 thousandths, because the idea is to be just smaller than the sprue opening. But when plastic gets injected through a nozzle, there's such a high shear rate because you're forcing it through such a small opening. It actually wears away at it, and it's measurable. You will see after, several months of running that orifice is no longer 118,000. It might be 126 thousandths. So, and that's just from the force of the plastic coming through. And if you don't think that makes a difference, put, 2 nozzle tips with those different diameter or orifice sizes on the machine, and then monitor the pressure, and you'll see a huge difference, and it's measurable. So, these are some of the things that you really got to keep an eye on, but temperature control on that nozzle. And, there's certain molds that have like a deep well that require an extended nozzle, and that's trouble. That's got trouble written all over it. So when you have to use that and your hand's forced and you've got to put like extended heater bands and things like that on there just to run a job, hey, we're custom molders and we got to play the cards that we're dealt with. You do it, but then when that job is done, you take that equipment off. It's only for a certain job. And, you may want to go as far as just keeping that nozzle tip taped to the top of the mold as it sits in the tool room so that you know exactly where it is the next time the job runs, and you've got all the equipment cataloged.
Great. Well, with that, I think we're out of questions anyway from the audience and elsewhere. And I want to leave with some final comments. And Larry, I think, is going to take the mantle there of providing some final comments to us. So go ahead, Larry.
Well, thanks, Joe. Well, just we know it's a complex business. You guys are facing a lot of pressures out there. There's a lot of dynamics. And, we just hope that we've given you a little bit of insight as to how you can optimize your operations and find a few pennies in your pocket. And with that, again, thanks for attending. And we look forward to any follow-up, any emails. Our contact information is here, and we look forward to hearing from you.
Great. With that, I want to thank Larry Hunt and Chuck Kritz of Nexeo Plastics for providing insights into operational efficiency. If you have additional questions, please feel free to reach out to them directly at the email address listed on the screen below. I'd also like to thank you, the audience, for watching. I want to also remind you that tomorrow at noon, we'll hear from Cannon, Virginia on how to make part cooling time more productive by using new technology. And we wrap up this week with Fortify, explaining how to make molded prototypes in less than a week with 3D printed tools. Have a great day, and we'll see you soon.
For more than 45 years, customers turn to Nexeo Plastics for our plastics resin expertise. As a distribution partner, we understand that the right product needs to balance ever-increasing demands for quality, competitive costs, and sustainable solutions. With thousands of products from world-class suppliers, our team of experts can deliver the flexibility and innovative solutions you need when and where you need them. At Nexeo Plastics, expect more so you can do more.